Class 6 NCERT Maths. In this video, we will learn when to use HCF and LCM in word problems. Before that, let's quickly recap the basics of factors and multiples. Factor is a number which divides a given number exactly is called a factor of the given number. For example, factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Similarly, factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Numbers of factors of a number are finite. Highest common factor. The highest common factor of two or more given numbers is the highest of their common factors. For example, the common factors of 24 and 30 are 1, 2, 3 and 6. Now, if you can see here, the highest in these common factors will be 6. Therefore, the HCF is also 6. Multiples. A multiple of a number is a number obtained by multiplying it by a natural number. That is 5 into 7 is equal to 35. Here 35 is a multiple of 7 and 5. The product of two numbers is a multiple of both the numbers multiplied. Number of multiples of a number are infinite. Lowest common multiple. The lowest common multiple of two or more given number is the lowest of their common multiples. Over here in the given multiples of 24 and multiples of 30, the common multiples of 24 and 30 are 120 and 240. Here the lowest in their common multiple is 120. Therefore, the LCM is also 120. When to use LCM in word problems? Here are some keywords that help us identify when we need to find the LCM. When the problem involves repeating events. When we need to find the smallest number that is divisible by the given number. Looking for the least number minimum among many possible numbers or possibilities. Problem involving rounds or cycles. Now let us solve a few problems to understand this better. 3 bells ring at intervals 4 seconds, 6 seconds and 12 seconds. When will they ring together? Bell 1 rings every 4 seconds. So ringing times are 4, 8, 12, 16 seconds, which are multiples of 4. Similarly, bell 2 rings every 6 seconds, which are multiples of 6. Similarly, bell 3 rings every 12 seconds, which are multiples of 12. Now let us find the common multiples of 4, 6 and 12. Here, the least common multiple is 12. Even though 24 is also a multiple, since it's LCM that is least, we will take 12. So, the 3 bells continue to ring every 12 seconds. When events repeat at regular intervals and we want to know when they happen together, we find the LCM, that is the least common multiple. Question number 2. The number of students in 3 sections A, B and C of class 6 in a school are 30, 35 and 40. Find the minimum number of books required for the class library for equal distribution in class A, B and C. Multiples of numbers are infinite, so there can be many possible number of books that can be equally distributed among the sections. Since the question asks for the minimum number of books, we need to find the LCM of 30, 35 and 40. LCM of 30, 35 and 40 can be done by division method. So the LCM of 30, 35 and 40 is 840. 840 is the minimum number of books required for equal distribution in each class. When to use LCM in word problems? Question 3. Find the least number which when divided by 6, 15 and 18 leaves remainder 5 in each case. Many numbers can satisfy this condition, leaving remainder 5 when divided by 6, 15 and 18. Since multiples are infinite, we can find the LCM of 6, 15 and 18 to get the least number and then add 5. LCM of 6, 15 and 18 using division method will be 90. 90 plus 5 is 95, which is the least number which when divided by 6, 15 and 18 leaves the remainder of 5 in each case. Question number 4. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds, and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they again simultaneously change? After 7 a.m., the lights keep changing many times. Since this repeating event involves multiples, we find the LCM of 48, 72, and 108 to know the first time they will change together again. LCM of 30, 35, and 40 using division method will be 432. The traffic lights will change simultaneously after 432 seconds or 7 minutes 12 seconds. That means after 7 a.m. they will change at 7:12 a.m. When to use LCM in word problems? Question 5. Determine the smallest 3-digit number that is exactly divisible by 6, 8, and 12. We first find the LCM of 6, 8, and 12, and then we find the smallest 3-digit number which is exactly divisible by their LCM. LCM of 6, 8, and 12 by division method is 24. Smallest 3-digit number is 100. Now I find a number that should be added to 100 so that it is exactly divisible by 24. Divide the number by the divisor. So the quotient is 4 and the remainder is also 4. 96 is the fourth multiple of 24. The next multiple will be the required number. The next multiple of 24 after 96 is the fifth multiple, that is 5 into 24, that is 120. The smallest 3-digit number which is exactly divisible by the LCM of 6, 8, and 12 is 120. When to use LCM in word problems? Question 6. A boy saves rupees 4.65 daily. Find the least number of days in which he will be able to save an exact number of rupees. 1 rupee note is equal to 100 paise. The boy saves 4 rupees 65 paise every day. That is 465 paise. After some days, the total savings can be many possible amounts. These totals follow the multiples of 4.65 and multiples are infinite. Among these infinite possibilities, the question asks for the least number of days in which the total amount becomes an exact number of rupees. So LCM of 465 and 100 is 9300 paise. To save 465 paise, the boy needs 1 day. To save 9300 paise, the boy needs 20 days. Question number 7. If the number is divisible by 8 and 25, then by which of the following numbers will that number be always divisible? If a number is divisible by 8 and 25, it must be divisible by their LCM, that is LCM of 8 and 25. Let us find the LCM of 8 and 25 by prime factorization method. Now using the factor tree method, we can find the LCM of 8 and 25, that is 200. Therefore, any number divisible by both 8 and 25 will always be divisible by 200. When to use HCF in word problems? Here are some keywords that help us identify when we need to find a HCF. If they have given some number and are asking how we could divide them into equal groups or splitting something equally, or to find the greatest number that divides the given number. Arranging or distributing items exactly without leftovers. Finding the greatest common factor within the given numbers, or finding the greatest number that divides all the given numbers. Finding the largest possible size of a piece of cloth, ribbon, or wood, etc. Now let us solve few problems to understand this better. When to use HCF in word problems? Question 1. Two ribbons 24 meters and 20 meters long are to be cut into small pieces of equal length. What will be the maximum length of each piece? Here, the two ribbons of 24 meter and 20 meter are being divided into equal pieces of the same length. Let ribbon 1 length as 24 meters. Here the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Let ribbon 2 length as 20. Now the factors of 20 are 1, 2, 4, 5 and 20. Here, 4 is the highest common factor of the two lengths, 24 meter and 20 meter. So, both ribbons can be divided into equal pieces of 4 meter each. The 24 meter ribbon can be cut into 6 equal pieces of 4 meters each. The 20 meter ribbon can be cut into 5 equal pieces of 4 meter each. Therefore, 4 meter is the maximum length of each piece. When we divide things into equal pieces and want the largest possible size, we use HCF. Since factors are finite, the possible sizes are also finite. So, we find the HCF. When to use HCF in word problems? Question 2. 3 sets of science, Sanskrit and computer books containing 96, 240 and 336 books respectively. If they have to be stacked in such a way that all the books are stored subject-wise and the height of each stack is the same, then find the number of stacks. We need a number within the given number that divides 96, 240 and 336 exactly. The number must be less than or equal to the given number because the greatest factor of a number is the number itself. Since factors are finite, we have to find the HCF. Let us find the HCF of 96, 240 and 336 by long division method. HCF of 96, 240 and 336 is 48. So, each stack has 48 books. Let us find the number of stacks for each book. Stacks required for science book is equal to 2 stacks. Stacks required for Sanskrit book is 5 stacks and stacks required for computer book is 7 stacks. So, the number of stacks required in total is 14 stacks. Question 3. The length, breadth and height of a hall are 8 meter 25 centimeter, 6 meter 75 centimeter and 4 meter 50 centimeter respectively. Find the longest tape which can measure the 3 dimensions of the hall exactly. We need a length that divides all the given measures exactly. This length must be within the given measurements. Since factors are finite, we find the HCF to get the longest tape. Let us convert the measurements into same units. Length is equal to 825 centimeter, breadth is equal to 675 centimeter, height is equal to 450 centimeter. Let us find the HCF of 825, 675 and 450 by prime factorization method. By using the factor 3 method, we can find the HCF that is 75 centimeter. The longest tape which can measure the 3 dimensions of the hall exactly is 75 centimeter. Remember this powerful idea of LCM and HCF. LCM comes from multiples and multiples are infinite. So we find the least one. So whenever you see infinite possibilities and need the least number, think of LCM. LCM, that is multiple, that is infinite, that is least. HCF comes from factors and factors are finite. So we choose the greatest one within the numbers. Whenever you see a number within the given number that divides them exactly, think of HCF. HCF, factors, that is finite and is the greatest. That's it for this video. Make sure to subscribe, hit the like button and turn on post notifications so that you guys never miss out on a video that I upload.